saying, how would you define reduction in terms of electron transfer? How would you define reduction?
It's gaining electrons.
So you're not sure, right?
I think it's gaining electrons.
Reduction is gain of what? Of electrons. That's reduction, the gain of electrons. Okay? So basically, if you remember your acronyms, oil rig, remember that?
Yes.
Okay, so your reduction is the gain of electrons, while your oxidation will be the loss of electron. It's very important to recall this. Okay, very, very key to recall this concept. So let's look at examples, situations where we'll talk about redox, reduction, and what an oxidation reaction. Let's say we have a reaction between potassium and hydrochloric acid. Potassium and hydrochloric acid. What will be the product of the reaction? What will be the product of this reaction?
So will it be potassium chloride plus hydrogen?
Yes, plus what? Plus hydrogen, right? So you can balance this equation. So we got a 2 here, we got a 2 here, and we got a 2 here, okay? So this is basically the balance equation. Now, let's see how do we explain this reaction as a redox reaction. So basically this reaction is a redox reaction because both oxidation and reduction, okay, took place at the same time. So now we need to understand which element or which species is reduced and which species is what? Oxidized. Okay, so to explain that, we can use several concepts to explain oxidation and reduction here. You must have done oxidation number. So if you look at each of these species, rule for oxidation number tells us that the oxidation number of potassium here will be what? 0, because potassium is in its uncombined state. Potassium is not combined. Potassium is in its element form. So the oxidation number here is 0. Basically, a simple way to look at it is that potassium is not charged. It carries no charge here. So the charge on it is 0. So it's 0. Now here, hydrochloric acid, okay, if you try to look at it in terms of ionic compounds, okay, it's going to be H plus and Cl minus. So you can say that here, hydrogen is +1. Chlorine is what? -1. The same thing in potassium chloride. Remember your bonding, chemical bonding. Okay, potassium here will be what?
Potassium will also be 0.
Yes, if you want to represent this ionic compound in its ionic form, I represent this is K plus and what? Cl minus. These are the ions that came together by electrostatic force of attraction to form the ionic compound potassium chloride. So that tells us that what? Here, potassium carries a charge of +1. The chloride carries a charge of -1. So potassium is +1. Chloride is what? -1. Then this hydrogen, is this an element or a compound or an atom? This hydrogen here. Come on, not this one. This hydrogen Hydrogen.
What? Yeah.
Yes. Is it an element, atom, molecule, or compound?
So it's an element.
It's an element, yes, because it contains only one type of what? Atom. Contains only one type of atom. That makes it an element, correct? So if it's an element, the oxidation, it carries no charge. The charge is nil. So the oxidation is what? 0. Just the same way potassium has no charge, the oxidation is what? 0. Now, having been able to do this, we can spot an element that is oxidized or a species that is oxidized and the one that is reduced by looking at the change in number. So you can look at this. You said oxidation is a loss of electron. But we can also say oxidation is what? Increase in oxidation number. You can say this oxidation is what? Increase in what? Oxidation number. Increase in ox number. While reduction will be what?
Decrease.
Decrease in what? Ox number. Okay, because if you want to say gain of electron, loss of electron, if you are looking at the equation like this, you may not quickly tell which one has lost electron and which one has gained electron. So if you use oxidation number, you can easily tell which one has increased in oxidation number and which one has decreased in oxidation number. So let's see this. Potassium moved from 0 to what?
So
To plus 1. Is that an increase or a decrease?
it's an increase.
Okay, it's an increase. So that means increase in oxidation number is what? Oxidation. That means potassium getting to this potassium ion is what? Oxidation. So if that is oxidation, it simply means that potassium has lost what? Electron, because oxidation is the loss of electron. Can you see the way we combine the two now to arrive at something tangible? So it means that your potassium K, okay, will lose what? Electron. Okay, potassium losing electron to form what? To form potassium ion, K plus. You see that, K plus. So now here, chloride is not changed. Chloride is -1 here, is -1 here. It means chloride is not changed. So let's check hydrogen. Hydrogen moved from what? From 1 to what? To 0.
Yeah.
So what would you call that?
So reduction.
Reduction. So that means reduction is a decrease in oxidation number, which means gain of what? Electron. So it means that hydrogen, okay, ion, H plus, did what? Gained electron to become what? Hydrogen. Okay. You see that? Good. To become hydrogen. So if that is the case, hydrogen is a diatomic molecule. So it's going to form H2. Can you see what I just did now? 2. I multiply by 2. Therefore, I'm going to multiply the number of electron gained by 2 and number of hydrogen ion by 2. Do you understand this?
Yes.
Okay. So we got that. So because the number of electron loss must be equal to the number of electron gain, I will also say we have 2K minus 2E to give us what? 2K plus. So you can see we have a half equation. This is called half equation. Half equation that represents oxidation. Then we have another half equation that represents what? That represents reduction. So the two of them happening together, we call the reaction what? A redox reaction. A redox reaction. So this will be a good reminder of what redox is, so that when we get to electrolysis, we apply it in electrolysis, you'll be able to understand the concept of half equation, reduction and oxidation reaction. Okay, now to just use this as a teachable moment, if you look at here, we notice that chloride is not changed. It's -1 here and -1 here. Species like this that remain unchanged, okay, chloride is unchanged. Species like this that remain unchanged, they are referred to as what? Spectator what? Ion. Spectator ion. Do you remember now? Spectator ion. They are not changed. They are just onlooker in the reaction. They are not changed at all. So that's an example of a spectator ion. Okay? A spectator ion is not changed in the reaction. Okay? Especially the oxidation number is not changed. If it was -2 as reactant, it will be -2 as what? As product. So that's a spectator what? Ion. Now to be able to reinforce this concept properly, because I need to lay background for that electrolysis so that you get it once and for all. Let's look at a few things about ionic compounds. Ionic compounds before we jump into that electrolysis. A few things about what ionic compounds. You know, for ionic compounds, we know that ionic compounds do not conduct electricity. Okay, can you describe the way they conduct electricity for me? Ionic compounds. So ionic compounds could be solid, and it could be what? Molten.
Or a solution.
Or solution. Brilliant. So can you differentiate between these three in terms of electrical conductivity with proper justification?
Solid doesn't conduct electricity because there are no free electrons.
Okay. The solid don't conduct electricity because what?
It has no free ions, no electron ions.
Okay. They have no free ions. No free ions. Okay, good. Yes, what about molten?
So molten will conduct electricity because the ions move freely.
The ions move freely. Okay, good. What about solution?
So it will also conduct because it's moving freely.
Okay, solution will also conduct because it is what? It is moving freely. Yeah. Brilliant. So, having established that, let's see an ionic compound, sodium chloride. Okay, if it dissolved in water, okay, want to see all the ions that will be there. You have sodium aqueous plus what? Chloride what? Aqueous, right?
Yes, sir.
So what this simply means that water is dissolved. These ions are solvated by water, surrounded by water molecule. Okay, good. Now, if I have a container that contains sodium chloride solution, I would expect that inside that particular solution, there will be 4 ions. And I need you to listen carefully. There will be 4 ions. 1, sodium ion. 2, chloride ion. And the 3rd ion will be your hydrogen ion. From what? From water. The 4th ion will be what? Hydroxide what? Ion. That will be the 4th ion. The 4th ion will be hydroxide what? Hydroxide ion from water. So basically you are saying that even your water H2O, okay, somehow, okay, can split into hydrogen, okay, and what? Hydroxide what? Ion. Okay, So even though water is a covalent compound, but it's one of those compounds called compounds of intermediate character. You know, they behave somewhat like ionic in nature, but they are covalent. Okay, so you can see water can split into this. And that is why ionic compounds can dissolve in what? In water. Ionic compounds dissolve in water for this same reason, because the dissolution is based on like charges what? On like charges attract. Okay, so that is why this sodium ion will be surrounded by what? By the negative part of water, while the chloride ion will be surrounded by the hydrogen plus, okay, in water. So sodium chloride will dissolve. So essentially, I'm linking this to electrolysis. So let you know that in aqueous compound, you have what? 4 ions present there. Okay, 2 ions from the solute, which is the sodium chloride, and what? 2 ions from, of course, water itself. So what if I have sodium chloride and it is heated? Sodium chloride is heated to now form sodium chloride liquid. How many ions do you think will be there? How many ions will be there?
Only 2.
2. Yeah, because there is no water, right? So basically, we have sodium chloride, sodium ion and what? Chloride what? Ion. Yeah. So for electrolysis of molten compound, we have to contend with what? Competition. Yes, we have to contend with reactions between what? Between 2 ions. But for electrolysis of aqueous compound, we have 4 ions that are what? That are involved. This foundation is very key to understanding of electrolysis. Any questions so far?
No, sir.
Okay. So now, having looked at that so far, your syllabus also wants you to remember, okay, that electric current is due to the flow of what? Electrons. Electric current is due to the flow of electrons from negative pole to what? To the positive pole. So now we need to look at what we call an electrolytic what? Tank.